Hello and welcome back to the Raspberry Pi coding channel. This is video 4 in my new series of humans versus AI. And in this video, we're going to introduce for the first time the concept of a player, which introduces the notion of state, which is going to form part of our machine learning pipeline. Quick reminder, I have a Patreon account, and for those who are patrons of mine, big thank you, and you can access the code directly in Patreon, which is where you can copy and paste it, and you have early access to videos as well. So if you'd like to support my work, that would be lovely, and this is how you can do it if you wish. Moving over then to my code editor, we'll have a quick look at what's changing in this video then. Well, a quick reflection on the last video. I won't go into detail, don't worry, I won't be going over the same ground multiple times. But the last video was all about rendering a texture of our grid in an efficient manner. And we created this method here to bake the texture into memory and then to render it with every frame as part of the onDraw loop. So if you recall, within the GameApp class, we have a couple of methods that run with every frame. OnDraw is one of them, onUpdate is the other. OnUpdate is where we update the game state, OnDraw is where we draw the assets, and we had an inefficiency caused by rendering a nested loop of creating vector features, and we solved that by baking those into a texture. In this video, we are going to add a player, this concept of a player, by creating a player class. So let's have a look at what's changed then between the last code example from the last video and this one. The first thing that has changed is we've introduced two additional imports, math and random. These are going to be used throughout this video. Math is going to provide us with mathematical operators such as square root, which will be used in calculating the distance between players. And the reason we want to know the distance between players is so that when we set their initial position on the grid, they're not too close together at the start. There'll be many other reasons we want to use math, but that's the first one. And random, of course, we're going to be using to randomize the position of the players at the start. So that's why we've got two additional imports. So we now have 4 imports altogether. Arcade, the library we're using for the game engine, random and math, and pillow that we used in the last video to create the baked raster, the grid being baked onto the texture. Okay, the same thing as before, the same constants, except we've got 2 new ones. We've got player min distance and number of players. A minute ago I just mentioned we're going to use the math library to calculate the distance between players. Well, the boundary for whether 2 players are too close together is defined by this value, player min distance equals 20. 20 being in units of grid cells, not pixels. 2 players cannot start within 20 grid cells, in this case, of each other. And we'll be creating a function that enforces that logic. And then, of course, we've got the number of players, which is self-explanatory. As before, we've got the GameApp class, which inherits from Arcade window, which is how we get access to Arcade library. And in the constructor of GameApp, we've got 2 new declarations of parameters or variables. We've got players and we've got number of players. Number of players, self-explanatory. It's just the number of players that's coming from the constant above. And then players is an array that's currently empty. And this is going to contain the objects. Each player is going to be an object. The number of players we have can vary, and they'll be populating this player array. So in a sense, this is the first piece of state we're going to have in the game. And we're going to keep going down now. These functions, of course, by now, if you're following my videos sequentially, are going to be very familiar. The setup function is the function that I wrote. It isn't part of Arcade. It's run right down here before the game loop starts. And it's where we do all of our setup, which at the moment is very basic. It's just rendering the pre-rendered grid into a texture. Well, we're going to add to that now, or soon, by adding the setup code for the players, because we have to instantiate the player class that we're going to look at in a few minutes and create multiple objects, one instance of a player class per player. And we're going to need a function that can do that, and this is where it's going to go. So I've just put a placeholder for that, because the players need to be set up, of course, before the game starts. So it makes sense, it goes in there. And then we've got onDraw, which is where we render everything. We're currently rendering the texture for the grid. Well, we also need to render the players so we can see where they are. And then if we scroll down, we've got the first change in real terms here, which is the start of the player class. So there are only 2 classes in this file so far. We've got GameApp which we've been seeing throughout, and now we've got a new one, player. I will pause and mention that separating out some of the content of this file into its own separate files will happen, and we will tidy this up. I'm keeping it simple in one file for the time being so that we can work through it sequentially. But there will be a video where we split this all out into a more sensible structure in separate files. Anyway, back to the point of the player class. So the player class really at the moment just has its constructor, which gives us the state. I haven't populated it with methods yet. That'll come in the next file. And what we've got is an ID, which identifies the player. We've got an X and Y coordinate, and we've got a color. These are the properties that define what is a player. So in a sense, that is the player's state. And these variables are going to be very useful when we come to train our agent. So that's it. That's all we've got for the first file. So let's move on to the next then and begin putting some more actual code to this. So in this next one, in 3.1, what we do is we haven't touched the placeholders in these functions, so they're the same. What we've done is we've completed the player class. So we had the constructor before in the last file. Now we've added a couple of other bits and pieces. So you'll have noticed in the constructor from the previous file, we had the color as a property of the player, but we had this function assign color, which didn't exist yet. So the first thing we've got here then is the definition of that method, assign color, which is a player method. And what we're looking at here is a little bit of conditional logic, which says if the player ID equals 1, then the player will be green. Otherwise, assign it a random color. And I'll just pause on the reason for that. That's a decision I made so that I always knew that bright green is the player who could be controlled by a human. The game will allow us to run it entirely with AI eventually, but we also want humans to be able to play, and I wanted to make sure that one of the players was quite distinguishable as a human when I wanted to be a human. So I've made that decision there. I'll probably change it in the future. That's why that's there. Random color belongs to the player class as well. So we've got another method, and this will change, but I wrote it just to get us going. Random color is a method that returns an arcade color. This is the list of arcade colors, and we use the random method of choice to pick one of them every time it's called. So it just returns an arcade color. So basically, when the constructor is called for a new player to be created, it gives the arguments that are passed to the constructor will be an ID, a position in X and Y, and then it will automatically self-assign a color randomly for players who are not ID 1. And for ID 1, they'll be assigned as green. Hopefully that makes sense. The other thing to show on this file is I've created a random position method, because we're going to need that when we set up the grid with players. And this is really simple. It uses the random or randint method, which comes with the random library. And all that does is it takes two extremes, a start point and an end point, and returns an integer between those 2 points. For us, random position method takes two arguments, grid X and grid Y size, and therefore we're using them here to define the range of numbers that random int is going to return. It's going to be between 0 and the size of the grid in X, and 0 and the size of the grid in Y. And as you can see by the comma between them, this method is returning two numbers, which have to be unpacked when we get the result. So if we go to where random position is being used, which it isn't yet, but when it is, you'll see that we're returning two numbers. One for the X position of the player and one for the Y. Okay, so that's clear. That's what random position is there for. It's not being used yet, but it's being shown here. And again, just to reiterate, we've now completed the necessary pieces for the player class definition. Right, so on to the last part. So this is the final file. So we've seen these new parameters. Now in the setup method, we have not a placeholder, but an actual called function, setup players. And it's populating the players array, which is what we need. So when setup is run, we're creating an array of players, which is exactly what we want before the game loop starts. So we'll have a look at setup players in just a moment. But before we do that, we're now looking at the onDraw method, the arcade onDraw method, and we can see we've got a new piece of code here. This is the rendering code to render the player. Now we haven't seen the players being created yet. We're going to look at that because that happens in setup players that we're about to have a look at. But just for a minute, assume that the players have been created with the parameters that you've seen in the class. Then in which case we're able to draw the players within the draw loop, and we're doing it by looping through all the players that exist in the players array. We calculate an x and a y position based on the player's state of position x and y. We also multiply by the tile size to make sure that we put it in the right place in the window, and we add half a tile again to make sure the player's position is centered within a cell. So that's what this is for x and y. And then we use the arcade draw circle filled method to draw at those positions, x and y, with the circle which has a radius of tile size of 2, which means the diameter will be a tile size, and therefore it will fill a tile. And the last thing to mention is the color. The color is obtained from the property of the player. Okay, so hopefully that's clear. That's a drawing code in Draw. So for every frame of the game, a player or players will be drawn at a position defined by the state of the player and the color, which is an intrinsic property of the player class and that particular object. Okay, on update, which is where game state typically is updated, hasn't changed in this video. The player class hasn't changed since we discussed it a few minutes ago. What we do have is two new methods. The first one is setup players and the second one is distance. The reason we have a distance method is because we need it to calculate the distance between players to make sure that they're not put too close together when we first create them. And that's the reason this function, which is actually very simple in what it's trying to do, looks a little bit more complex. What we're trying to do with setup players is very simple. We just want to create an array of player objects instantiated with coordinates x and y and an ID. That's it. That's all we're trying to do. And actually, we will have a quick sneaky peek inside this method. We can see that's happening here with a new player being created by instantiating the class, the player class, giving it an ID and giving it coordinates. Okay, so let's have a look what's happening from the top to the bottom. We create a temporary array. We loop through using a variable called, using a variable called player ID, which goes from 1 to number of players plus 1. I decided to start the player ID with 1 instead of 0. It's just a personal choice. The loop then is infinite while true, and that's because I want to keep looping until the random number generator picks a coordinate which is not breaking the rule, which is here, which is that the new player is not within the distance of player min distance from existing players. So it's going to try, create one, compare it to the existing players, and if it's too close, it'll go round again. If it's not too close, which will run this code, it'll append that player object to the players array, which is temporary, and it'll keep doing this until we've gone through all of the player IDs, and then it'll return the players that have been populated in the object array players. So basically, by the end of this function running, it's populated with, say we had 4 players, which we do in the constants at the moment, it will return 4 player objects with coordinates x, y, which are not within a player distance of 20 grid cells. That's what this method will do. So how does it know about distance? We have a distance function, and that's what's being called here. The distance function simply takes a new player and compares it to an existing player, and it's calculating the Euclidean distance between the players, and it makes use of the square root function from the maths library. So it just makes sure they're not too close together, using the grid cell coordinate space, not pixel space, because that's what the x coordinate is in the player class. Okay, so there's a lot of talking there, but hopefully it's reasonably clear what's going on. So if we play this, we should see some players appear on the grid. There we go. We've got random colors, random locations that are no closer than 20 grid pixels, grid sections, cells, tiles apart. So it's worked. You'll also have noticed, those eagle-eye viewers, that we had a print statement in here using an f string to print the coordinates of the players that are added to the array. This is just to validate that they are indeed sufficiently far apart, but we will get rid of that in the next video. Okay, so I have finished, but just to rub it in and make sure we're absolutely clear, let's just run through this one more time very quickly, and I will do it quickly. We run app setup start first before the game loop starts, and setup is going to go up here and it's going to create the baked grid, which we know about from the previous video, and it's then going to run setup players, which is going to populate an array of player objects with coordinates x, y, a color property as well. The coordinates x, y are going to be random, and they can't be within a distance of player min distance. Okay, and that's what's going to happen in setup. And then, of course, arcade then gets kicked off as per arcade.run, and it'll start running the loop of update and draw. Update hasn't changed, but onDraw has, and onDraw will draw our players in every frame. And eventually, we'll be able to animate. Okay, that's it. In the interest of keeping the video on time, I'll wrap that up. Hope you found that useful. In the next video, we're going to allow the player to be controlled. So a human being can control the player using WASD, but also it's necessary, of course, to allow a player to move around the game environment, because that's exactly what the reinforcement learning game agent is going to be doing. The agent is going to need to move in order to learn its environment. So I hope that was useful, and I will see you in video 5. Thank you very much.